You're not going to want to miss this episode of the AI Show where we talk all about fine tuning. There's no reason not to do it. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're talking all about fine tuning. There's no reason to not fine tune anymore. My friends Alicia and Omkar. How you doing, my friends?
Hello. Super excited to be here.
I know. I think you've been on a show before, right, Alicia?
Uh-huh.
But for those that don't remember, how about you reintroduce yourself? Tell us who you are and what you do.
Yeah, I'm Alicia Frame. I'm the product lead for fine tuning on Azure AI Foundry.
And Omkar, is this the first time? Because I've worked with you before, but is this the first time you're on the show?
Yes, it is.
Yes. Tell us who you are and what you do, buddy.
Hey, I'm Omkar. I'm partnering in crime with Alicia from the engineering side, working on Azure OpenAI and OSS fine tuning.
Fantastic. Okay, so Alicia, I hear fine tuning, and I'm like, do I need to be a full-on data scientist to do this? What do you think?
No. And so 2 years ago, I think I was on this show and we talked about to fine tune or not to fine tune. That is the question.
Mm-hmm.
And I've spent the last 2 years trying to answer that question. And the answer is yes. Or at least you should try. And so what we've spent our last 2 years doing as a engineering team is making it so easy that there is no reason not to try fine tuning anymore.
All right, and I see you brought some slides. Let's go to those so you can give us an explanation of what it is and maybe why we should do it. So let's do that.
So fine tuning has become really a critical skill in the last 2 years. 2 years ago, everyone was like, I'm going to start my own AI startup. I'm going to build a foundation model from scratch. It's going to be beautiful. It's going to be worth $1 billion. Turns out that's super hard, super high risk, and a lot of those models suck. So then last year, the hype was, oh, I'm going to just use retrieval for everything. It's going to be amazing. It'll just work out of the box. And that works pretty well. It gets you most of the way there. But if your model doesn't know a lot about the thing you're retrieving information about, or if your model doesn't really know what to do with the information it's retrieved, it can't tell what's real or what's irrelevant, this is where fine tuning comes in. What we've seen is base models have become commoditized. I probably shouldn't say this, but like, Llama 4, OpenAI 4.1, Claude from Anthropic, they're all great models. You're going to get good results from them, but they're not bespoke to your use case. So what we've seen is as models have become kind of more interchangeable, the secret sauce is now fine-tuning them with your data, your use case to create something unique. And it's pretty easy, pretty low cost, and there's no reason not to try. And in terms of just like, how does this work? If we start from how do you build a foundation model? You have pre-training, which is unsupervised, consume the whole internet, predict the next token. Then you have post-training, and your pre-trained model, not great. You do post-training to make it useful. First, you start with instruction tuning, where you show it, here's task-specific data, here's prompts and responses. This is how I want you to behave. And then you can do alignment tuning, typically for safety, but this is often, teaching the model, if you could answer A or B, I'd really you answer A, not B. And put together, these 3 steps give you your generic large language model. Now, fine-tuning is a cheat code. You get to take that off-the-shelf frontier class LLM, and you get to add your data to it. And so instead of repeating that pre-training step, you get to start from the foundation model, and then you can apply instruction tuning and or alignment tuning to make that model custom for your use case. You can either instruct it on how to do a specific task, teach it about a new domain, or show it, I would really prefer you be upbeat and cheerful rather than depressing. I don't know. Align it however you want, and now you get your custom model.
And this is cool. Can I pause right? If we can go back here just for 1 second. This was like, because I remember I used to do a lot of image stuff, when we had the convolutional neural network. No one ever like started from scratch. They always started from like a base model, and it was called transfer learning. Is this similar-ish?
Yeah, I guess we kind of forgot the notion of like, maybe it's a bad idea to start from scratch. When it was like, everybody's going to start their own startup, forgot that. Yeah. Then we remembered, and then it was like, oh, I don't need any customization, just off the shelf, I'll give it good instructions. And so now we're kind of back to where you're talking about. So we just, keep repeating, rinse and repeat.
Yeah, and like now that you say this, right? It's like, oh yeah, we used to do this all the time. We would download a little. Remember, there was like the YOLO model. You would download it and then you would fine tune it. We wouldn't call it fine tune. We called it transfer learning. But this is the same thing ish. Yeah.
Let's go ish. Yeah. Conceptually similar. Let's go with that one. So you're taking something off the shelf. You're basically retraining it with your own data. You're adjusting a small subset of the weights to change those next token predictions. And now this model knows about your stuff that you would maybe rather not just feed into the internet. So custom for your use case.
That's
Amazing.
cool.
And then, so like, why are people doing this? Four really pretty obvious categories. Most people think fine tuning and they think I'm going to make the model smarter. I'm going to teach it about something it doesn't know. I'm going to teach it to do a specific task. I'm going to make it more accurate. That's pretty obvious. Another kind of big class of usage is either cost reduction and efficiency, or decreasing latency. And these are two sides of the same coin. This comes down to, I want to take a small and cheap model and I want to make it as good at a task as a large and expensive model with fine tuning. And Omkar is going to show you this in the demo. It's called distillation. I'm going to teach 4.1 Nano to be just as smart as 4.1 at my use case, and I'm going to save a lot of money, have better performance. It's going to be fast. It'll be beautiful. And then the final category is really just risk mitigation. And before we would talk about, safety alignment, base models are pretty good at that. But what's becoming really important is we have all of these multi-agent workflows. And when you have 100 agents you could use or 100 APIs you could call, it's really important the model doesn't call the wrong one. And it becomes super complex to include all those instructions in the prompt. So enter fine tuning, where you can teach the model, this is when you call this agent, this is what you do with those outputs. And it becomes really an essential tool in your agent toolbox.
That's cool. I mean, can you do alignment? Like, because I love the agentic loop. You ask it a question and it tells you what tools to call. Can you align it on the tools it calls as well?
You can teach it so let's say you have two tools that might be similar, and it could just as likely call one or the other. You can use that alignment training or regular supervised fine tuning to teach it, what, I really would prefer you call tool A. And so like one customer we've worked with, Oracle, is building these like EHRs that use tool calling, electronic health records. Doctor goes in, they're like, what is Alicia's blood pressure? Super high. And they need to call the right tool to pull that data back. And what will happen is, imagine if your doctor calls the wrong API. That would be really bad.
Yeah.
So they can teach it, call this API, not that API. And you can think in the medical setting, there are going to be APIs that look very similar, right? Like labs versus blood pressure versus, heart rate. And they have to align it to make sure it's calling the right ones.
So there's a couple of things. Omkar, we'll go to you if you want to add to this too, and Alicia, you mentioned like a couple of different things. You said supervised fine tuning. You also said distillation. So what are the categories there? And can you help us sort of think about that a little bit? We'll start with you, Alicia, and then we'll go to you, Omkar.
Omkar's laughing at me for digging myself into a hole.
I know. I knew it too. I knew it too.
Leave me alone. So there's techniques for training. So you can use supervised fine tuning, which is like I give it prompts and responses and it learns to copy me. And then there's alignment training. An example of that is direct preference optimization, or DPO, where you give it a prompt and two potential responses. And you say, this is my preferred response. And this is the response that I would not like. And these are just examples of, training techniques. How do I teach the model to behave the way I want? Distillation is kind of a specific application of fine tuning where you have a large model, let's say 4.1, frontier model, generating training data for that small model. And so I'm going to use supervised fine tuning with data generated from 4.1 or even, let's say, 0.3, a reasoning model. And then I'm going to train that small model, 4.1 Nano, 4.1 Mini, with that data. And I could use SFT if I wanted to. I guess I could use DPO, probably shouldn't. And then Omkar can tell you if I've lied.
I think that was exactly correct. And in our demo, we'll show you this, Seth. We will show you a way in which we'll do distillation from an 0.3 model to a 4.1 Mini or 4.1 model. And we'll also show you reinforcement fine-tuning on an 0.4 Mini model itself. So
Okay, and cool. And the cool thing about distillation, again, like if people didn't like, maybe I'm just getting this, and you can tell me if I'm wrong. It's not that you're putting a big model into a small model. It's that you're directing the output of a specific subset of data that you're pushing into that model into the other one. So it's going to be very good at the thing that you have the big model. You're like kind of I like distillation. It's like you're pouring very specific bits of the big model into the small model. Is that a good intuition?
Yeah, it's not like I'm going to distill 4.1 nano to be just as good at all things as a reasoning model. That would be a brilliant technique. Instead, what you're going to do is, let's say you want to train a model to do your podcast for you, take the transcription. You don't want to manually annotate all of that data, I assume. So what you would do is maybe use the frontier class model to consume the transcripts, generate the notes, and 4.1 nano off the shelf is not great. So you'll train it with that data to generate the higher quality responses. So it's really task specific.
Yeah.
Yes,
and it also lets you retain the latency benefits that you get from using a smaller model instead of having a bigger model. So that's
it's like focusing the model on a specific task and letting the big brother or sister model be like, this is the bits you should know specifically for this thing, right?
Exactly.
And we call it the teacher model.
Teacher, see, there you go. I think we should call it the big sister model. You know what I'm saying? All right, Omkar, you were going to show us how this actually works. Can we go to that?
I'll be delighted to. So what you see over here is the stored completion UI. So what we have done here is, let's say you have a model into production, which is performing pretty well, but it is big and it has higher latencies, and you want to replace that with a smaller model that you can use for latency improvements or cost improvements. So as you can see here, Seth, you can go over each and every chat completion. You can see the metadata. You can see the entire input output of the model that has been captured. And then what I'm going to start with is, let's start first evaluating how this
Hold on, before we go there, is this so basically when you have your model in production, how you can make it so that it saves this stuff as a data set?
Yes, absolutely. So what you can do is, when you have data in production, you have a header that you can pass which says store equals to true, and those completions we will store for you so that you can analyze them later.
Oh my goodness, that's amazing. So effectively, you could start an application. Hold on, I want everyone to look at our faces when I say it. So effectively, you can start an application with a big model, and over like 6 months, get like exactly the right things with them, and you can save those things, and then you can distill a model from that. Is that a good way to look at it?
Absolutely, yes. So that's what we can do, and that's becomes your starting point. And what I can do now is I'm going to take all of this distilled data, or rather captured data, and start evaluating this across different options. So what I'm going to do is, let me take this capture data and start evaluating against a set of base models. So let me choose, say, how this is going to perform against 4.1. I can also add a few more, let's say 4.1 mini.
So as you're doing that, keep clicking around. So is what's happening here, you're basically saying, I wonder what would happen if I used a different model on this. Is that what this basically is?
Exactly. So we want to replace our O3 model, which is there in production, with a smaller model, but we want to see which of these smaller models currently perform as is on this data.
Okay.
So we're not tricking you and pretending to fine tune to add value. He's going to show you the base models are not great at this task.
I see. Hold on. So as you're going, you basically can actually be like, I wonder if a smaller model will actually even work. You can just test it, and you might be like, well, I've been using the wrong model the whole time. I don't need to distill. And this is one way to do that. But then you can learn that the other ones aren't really going to do a good job at this point, right?
Correct. Absolutely. And then you can add a testing criteria. Now you have a bunch of testing criteria that we have shipped. The one that I really like is the model scorer. So here what you do is, you can use a bigger model to grade how the responses are. So let's say I'm going to use an O3 model and a pre-built template called as an auto grader, which will give a score between 0 and 7, or the 1 and 7, on different parameters, whether the model was helpful enough, was it truthful enough, and things like that. And this comes out of the box. I didn't have to write anything for it. and just go ahead and add that grader and then submit this evaluation run.
And as you're doing this, is this something you can do with the SDK as well in code if you want to?
Absolutely. We showed this in Build 2025, and I'll share the notebooks for you. So as you can see over here, I have done this exact same thing from the
delightful
notebook, and you can see a lot of
that's really cool.
So as this is might take a few minutes to run, let me open up a already completed evaluation run, and we can see how these things stack up. So here's the result. So as you can see, the O3 model performs the best. It has like a 95% score. 4.1 is decent. It's 87. If you could just replace O3 with 4.1, and you will be fine for this data set if you're okay with this performance, but you'll get at it at a much cheaper rate. And there are other models that are also worth considering. So what I'm going to do next, Seth, is I'm going to go to store completions again. I'm going to select the same data set or the same set of completions and click on the distill button. What this allows me to do is now use this data that is already captured, convert that into a data set that is in the fine-tuned format, and then select, let's say, a GPT-4.1, like maybe a smaller one, maybe a 4.1 mini model, and use that for training. And this, again, you don't have to do any conversion yourself. It automatically happens behind the scenes for you. Now, let me select the training type. So this is something that we introduced, again, very recently, which is called the global training. This allows you to have training at a much lower rate and from a resource that is available in any region. Next up, you can change any hyperparameters that you want. I'll keep most of them as auto. This is a good starting point, but it allows you to change it as well. And then this is another new feature that we launched at Build, which is the automatic deploy after fine-tuning. So one of the things that has always been frustrating for me was, hey, I kick off a fine-tuning job. It might take a few hours. And after that, I come back, and then I have to still go ahead and deploy the job and before evaluating. So this avoids you from doing that. And the third big thing that we introduced in Build was the developer tier. This is great for evaluation because this allows you to do deployments without having any hosting cost. And this has a decent TPM, and it allows you to do evaluations before you can decide whether you want to take it to production or not. So this reduces the bar for trying out fine-tuning a lot.
Same price as a base model. So I don't want to hear any complaints about
and that's actually cool, right? Because one of the things is like this stuff, I mean, you're using big machines to do this work, and it's cool to be able to be like, is this actually fit what I need? And then you can go back and do more distillations if it doesn't. Okay, how long does this process take? Like, how long does the evaluation take, and how long does the distillation take?
So it depends a lot on the data. So typically, say, evaluation can take within, like, say, a few minutes, like 5 to 10 minutes, if your data size is smaller. And if you have, say, training typically takes an hour, a bit more than that if your data size is bigger.
Okay, this is cool. So what are we looking at here?
Yeah, so I have a completed run that I can open up. So this is a fine-tune run which we ran earlier. You can go to the metrics tab and go ahead and see the loss curves and accuracy. So this tells you over time, as the training is happening, whether the loss is reducing or not. And the model is learning. Once that's done, you can always continue the fine-tuning once you have more data. So this is a really cool feature where you can say that, hey, I started off with say around 100 records or 200 records, and see that, okay, things are looking fine before actually submitting a bigger run with, say, about 10,000 records or 20,000 records, which might take a few more hours. Okay, once that's done, we can go ahead and use the model to deploy. I have done the deployment before, so now let's go back to the evaluations and see how this stacks up with all the base models that we already had.
Oh, I see the story here. So you're gonna hopefully show that the new small model that's been distilled is also good. Am I getting this? Am I getting the story right?
Correct. So what we're going to show is, if you scroll over here, so this is all the models that we have trained, base models and fine-tuned models. And as you can see, the fine-tuned models have creeped up on the leadership board, and actually you can see now they are all above 90% pass rate for both the 4.0 and the 4.1 series. So that's an uplift of around 7 to 8% on 4.1 models, a lot more on the 4.0 model for this data set. And as you can see, even the 4.1 mini model now performs decently fine. So you can now make a choice to replace your base or the O3 model, which is a bigger, more costlier, more latency model, with any of the smaller, either the base models or much better, the fine-tuned models.
Yeah, and that's cool because, like, by the way, I'm a data science guy. That's what I was trained in, right? And 90% is good, 100% is bad. Something's really wrong.
So we're not lying to you.
Yeah, 100% is really, really, really wrong. And I remember, Alicia, just to come back to you, and let me go back to our phases here. I remember you said it's easier to mess up a model than it is to, when you're fine tuning it, than it is to just leave it. What's made it so that it's a lot easier and better?
I mean, it's still, you can mess up a model if you want to.
Mm-hmm.
Give us 10 training samples, run it for 20 epochs. That'll give you a bad result. But what we've done to make it easier is you've got that data creation from stored completions. And you don't even have to have like a prod model deployed that you're logging from. You could just have a model stood up and you could ask that model, generate 50 prompts and responses on this subject for me. So using that really smart model to generate your training data improves your odds of success. And then we've added, evaluation and better ability to kind of peer into, did I make this better or worse? Instead of just like opening the model and being like, hi, friend, are you smart? And hoping for the best. So we've added a lot of tools for observability.
That's cool. So another question that I have, and hopefully it's not a sensitive one, is, are you allowed to, like, are there rules on, like, I can distill from this model to that model? Is there like a chart or something? Help me out here.
There's no chart.
Alicia.
But there is a button.
There's a button, right? That tells. So is this something we're allowed to do? Like I'm allowed, because the thing is that's cool is distillation effectively means that I can generate an infinite size data set because I'm just pushing into a model, getting a data set out, and going over. Is that allowed?
Without like bringing the lawyers onto the call and reviewing the terms, the answer is yes. As long as you're using AI Foundry, using the serverless fine tuning, you're good. You can use the stored completions to generate your data, or you could, do prompts and responses and a script, and then using that serverless fine tuning for the OpenAI models or the mass models, you're golden. Deploy it on Azure, and you're good to go. Well, we wouldn't give you a distill button if you were not allowed to do that.
That's true. That makes sense. Well, I'm convinced. I am convinced that I think moving forward, like whenever I build an application, I'll start with a big model to learn about like what actually is going on, and then I can progressively move to smaller, more distinct models for tasked basing, especially when we go agentic, right? Because agentic means there's multiple models doing things, and we can have each agent like be very good with its single model to do specific. Is that the right intuition?
Yeah. We have one customer who has 127 distinct fine-tuned models in a multi-agent workflow. And that was also my face when they told me that.
Wow, my face went like that because it was almost 128, which means it would have been perfectly fitting in like binary, but it didn't happen. Maybe they'll have one after that. All right, so where can people go to find out more?
Let me pull up that slide.
There's a link down here. Is it this what you want to show? Model customization, meet the experts, booth content. Is that the stuff that you had, Omkar?
Yeah, this has the notebooks for both the one that I showed right now and also the reinforcement fine tuning. I think there might be other content, Alicia, that you want.
And then this one, right? Customize a model with fine tuning. What's this?
I don't know where that takes you.
Ooh, well, it's gonna be amazing. But you have a slide, right?
Yeah, there's a slide in my deck. aka.ms/fine-tune now.
Ooh, aka.ms fine-tune now. I'll put that up. Thank you so much for spending some time with us, my friends.
Thank you.
And thank you so much for watching and learning all about fine-tuning. There was no reason not to. You should start that today. Thank you so much for watching, and hopefully we'll see you next time. Take care.